I am going to show how I extracted strontium nitrate from road safety flares. It's possible you may find these at your local auto parts store. I ordered mine from Amazon. In addition to the flares, you will need two chemicals, sodium carbonate and nitric acid. It's possible you won't need either of these chemicals if all you want is to make red pyrotechnics and you don't mind if your strontium nitrate has some potassium nitrate contamination along with a little potassium chlorate. If you would like strontium carbonate, you can skip the nitric acid and you will only need the sodium carbonate. Inside the package, along with the flares, was a card that contained some useful information. It listed the location of a website that showed the material safety data for this product. This sheet shows the ingredients contained in the flare, which is exactly what I needed. Looking at the list, I see only 3 ingredients that appear soluble in water. Those are strontium nitrate, potassium nitrate, and potassium chlorate. So the first order of business is to remove the powder from each of the 3 flares. First, I remove the plastic caps from the top of the first flare. Here I am using a hacksaw to cut the flare open about 2 inches from the top. This is the balanced equation for the reaction I am going to perform next. It has been normalized for 1 gram of strontium nitrate. The addition of sodium carbonate to the solution will form strontium carbonate and sodium nitrate. The strontium carbonate is insoluble and will form a precipitate, but the sodium nitrate is soluble and will remain in solution. The other two chemicals, potassium nitrate and potassium chlorate, will not react with the sodium carbonate. I use an uneducated guess as to how much sodium carbonate I will need. The exact amount will be determined by monitoring the pH of the solution as the sodium carbonate is added slowly in incremental steps. calculate, if possible, how much of the sodium carbonate I used. So I do remember that I had the beaker with enough liquid that was almost 200 milliliters. But you can't trust those. They're not that accurate. So I think that's about how much it was. I'm going to measure that volume more accurately. So there's 100 milliliters. So it was about 198 milliliters, which was very accurate actually. So then I'll do a calculation and figure out how much sodium carbonate that I've used. So for my second batch of sodium carbonate solution, I had added 80.65 grams and had a volume of 198 milliliters. So that works out to be 0.4073 grams per milliliter. Now, so I had 198 milliliters minus the 78 that was remaining, means that I used 120 milliliters of my second solution. So multiplying 120 by 0.4073 means I used 48.88 grams from the second solution, in addition to the 125 grams from the first batch of sodium carbonate I mixed up, for a total of 173.88 grams of sodium carbonate. So from this value I can then calculate how much of the strontium carbonate that should have been produced. So I'll do that calculation now. So from the original balanced equation, which was normalized to 1 gram of strontium nitrate, so I used half a gram of sodium carbonate. So that means there should have been twice as much strontium nitrate present. So I had the 173.88 grams times 2 gives me 347.76 grams presumed of strontium nitrate. So you work that through, multiply 347 by 0.698. So there should be 242.74 grams approximately of strontium carbonate, and we should have also produced 279.25 grams of sodium nitrate. So we'll see how that works out as we go through the rest of this experiment. So just as a reminder, my estimate for the strontium carbonate was to be 242 grams. So let's see how close I came to that value. $212. That's not too bad considering I surely had some loss and my prediction wasn't super accurate anyway. So that's very acceptable. So that would be an 87% yield. So this is the sodium nitrate solution, which was the other result of the reaction. It also contains the other soluble compounds of the original flare powder, which is probably potassium nitrate and a little potassium chlorate. I think there's enough here that's worth saving because it has pyrotechnic uses. So I'm going to be evaporating the water out of this and see how much I can recover. Yes. So I like this pie plate method of removing water from solutions, especially if it's water-soluble compounds, because they tend to dry in a hard, crusty way, and if you use a beaker, they're very difficult to remove, and it's much easier to scrape out of the pie plate. Notice I keep the lid turned a little to allow the steam to escape. I'll just turn the heat all the way up. So for a purity test for my strontium carbonate, I'm going to attempt to do a flame test, and if it's clean, it should burn red in the flame. So I'm going to try that. First, I have this copper wire, which is not ideal, but it's all I can come up with. Ideally, you'd use platinum, but I can't seem to find any platinum lying around. So this is just the wire, and there doesn't seem to be much. Now I'm going to wet the wire, dip it into the strontium carbonate just so a little gets on the wire. That looks very orange. That tells me that I've had some sodium contamination. Even a small amount of sodium will impart and overwhelm other colors in a flame test. So unfortunately, I have more work to do. So I'm going to take a small amount of the strontium carbonate that I have and try and wash it more, just to get an idea of how many washings I'm going to have to do to get it clean. So here I've measured out 10 grams of the strontium carbonate. In this 500 milliliter beaker, I'm going to fill that up to 500 milliliters and try and wash out the sodium. And I'll do this until I can get rid of it, hopefully, and see how many times I do. And it'll give me an idea as to how much more washing I need to do on the larger amount. So I'll let it stir good, then I'll filter that. So now I'm going to see how much sodium nitrate I have. It's finally dry and I've got it ground up pretty well. So as you recall, the predicted amount of sodium nitrate was 279 grams. Of course, that does not include the potassium nitrate and any other solubles that were present in the original powder. So 171.8, which is a lot less than I expected. So I want to get this bottled and sealed right away so it doesn't draw a lot of water out of the air, as sodium nitrate tends to do. So after washing it twice, I'll put it on the hot plate and dry it out and then give it another flame test to see if I'm making any progress in getting the sodium out of there. So in addition to the two washings that I just showed, I followed that up with two more that I didn't record for a total of 4 additional washings and decantation of the strontium carbonate. So I've dried it out here. I'm going to do the flame test again and see if anything's improved. Here it goes. So it's very orange, so I don't know how to get the sodium out of there. There's obviously some contamination that I just can't get out. So I think the lesson here is stop when you have the solubles extracted from the powder and just use that compound for your red pyrotechnics. Don't add any of the sodium carbonate. But I'm going to press on with this sample anyway, convert it back to strontium nitrate by adding some nitric acid. And by some miracle, maybe it'll burn red then, but I doubt it. So here is the reaction that I'm going to do, which will convert the strontium carbonate to strontium nitrate. It's simply strontium carbonate plus nitric acid will yield strontium nitrate, and carbon dioxide gas and some water will also be produced. So normalize to 1 gram of strontium carbonate. You'll need 0.854 grams of nitric acid, and that should produce 1.433 grams of strontium nitrate, 0.298 grams of carbon dioxide, and 0.122 grams of water. So I'm going to add my nitric acid a few drops at a time to my dried strontium carbonate. Carbon dioxide should be released. By the way, this is about 32% nitric acid. I'm going to keep adding it until all of the strontium carbonate is dissolved. I'll try and stop it at the exact point when it dissolves so I don't have excess nitric acid. Something just occurred to me, so I probably should add some water just to make sure there's enough water present to dissolve the strontium nitrate, so I'm not fooled. Hopefully that's enough. So something interesting has happened. So as I was adding the nitric acid, suddenly the solution that was cloudy has now gone clear, except there is still obviously some solids, undissolved precipitate, still in there. So I don't know why that would happen. I'm going to try adding a little more acid to see if I can still get the CO2 bubbles. Yes, it still does. From here on, I'm going to go very slow to make sure I don't overshoot and add too much acid. I'm going to stir it and swirl it frequently. So I'm getting down to the end of converting my strontium carbonate sample back to strontium nitrate. So I had just a little bit of powder left that had not reacted. It looked like it had about stopped. Then I decided to apply some heat, and now I see it starting to bubble again. So I think near the end of this reaction, it's a good idea to heat it up and make sure it's completed. Ideally, I'll have just a little bit of strontium carbonate left. So here is my strontium nitrate solution, which is a tiny amount of the strontium carbonate powder unreacted. So I'm going to quickly filter that and then evaporate off all of the liquid. So now I put the solution onto the hot plate and I'll heat it up and evaporate the liquid. So now that the little sample of strontium nitrate has finished drying, I will weigh that to see what the yield was. .71 grams. So I started with 10 grams of strontium carbonate, so I should be expecting 14.33, and I got 13.71. So I'll see what the yield is. .95%. It's not too shabby. So I thought of a test I can do here, sort of a sanity check on this whole flame test thing. I remembered that in my old chemistry set I have some strontium nitrate. You can hardly read it. I can make it out. Probably won't be able to tell on the camera, but it does say strontium nitrate. So I'm going to do the flame test using this. So I take my wire, dip it in some water, got some strontium nitrate on it. Let's see what it looks like. It still looks very orange with hints of red. Doesn't look all that different from what I've been seeing. So maybe I'm not so far off after all. So now I'll do a quick flame test with my freshly made strontium nitrate. Well, it doesn't look all that red, but neither did my strontium nitrate from my chemistry set. So using my strontium nitrate, I prepared this powder as a test. It's composed of approximately 50% strontium nitrate, 20% potassium chlorate, and 30% of powdered sugar. So I've mixed that all together, and I'm going to take a little sample of it, put it on this little piece of aluminum foil, and see if I can get it to burn and look at the color that's produced. So I'll shut the lights down and get on with the test. So I'll take my copper wire and heat it up in my torch, get it red hot, then I'll apply it to the powder. Okay, that looked very red. It had a slight, maybe orange color, but mostly red, and it burned very well. Now this particular composition I just sort of made up off the cuff, so don't presume that it's some kind of optimum mixture. This was just a test to show if I could get a red flame out of my strontium nitrate. So to close out this video and to recap, I'll just say that what I've ended up with is about 162 grams of sodium nitrate, about 233 grams of strontium carbonate, and a few grams of strontium nitrate that I made by reacting some of the carbonate with nitric acid. So I'm going to keep the strontium in the carbonate form. I think it'll store better, and if I ever want to convert it to another strontium compound, it should be easier when you're starting with the carbonate. If I need strontium nitrate, I'll just make it as needed, and if not, I will have saved my nitric acid. So that wraps up this video. Hope you enjoyed it, and I hope to see you again in my next video.